Today I'm going to show you how I built a custom electronics workbench. The desk features a durable cutting mat surface, height adjustable motorized legs, a pegboard back panel to maximize space on the work surface, and an LED work light. To start, I collected some steel square tube from a local metal supply shop, as well as a sheet of plywood for the table surface. I decided to start the build with the backboard frame, since I knew I could work on the table surface while the frame was out for powder coating later on. After cutting the tubes to length with the drop saw, the mill scale needs to be ground off at the weld joints. This ensures the surfaces are clear of contaminants, which can weaken the welds. I'm not an expert welder, so after I finish each bead, I grind it off to hide all my mistakes. This helps me sleep at night and protects my ego. These are the steel pegboard panels I bought from Wall Control. The panels are high quality, but if I could go back, I'd buy the bare metal ones so I wouldn't have to grind the coating off all the tabs prior to welding. Now that the backboard is complete, it's time to build the shelf. This is where the lights will mount. It'll also serve as a convenient place to mount a camera for a top view of the work surface. The first time I welded this, it didn't fit together like I was expecting. The backboard frame had warped when I welded in the panels, so I had to redo it with a weld order that I could get away with. I also got this steel sheet from my local metal shop. This will be used for the top surface of the shelf. When I was cutting the sheet, it was sitting on the wooden blocks and the cardboard from the clip just prior to this one, so I was cooked alive while cutting it. Once the sheet was clamped onto the frame, I just tacked it all around until it stopped rattling. At this point, the frame was nearly done. I just needed to create some mounting arms which would be screwed into the bottom of the table. I calculated that 6 lag screws would be more than strong enough to support this frame, so I needed 3 holes per mounting arm. And finally, I could make the last welds of the project. No more warping metal for me. Before sending the frame off for powder coating, I did a fit test on a scrap piece of plywood I had, which turned out perfect. To make the surface last, I wanted a large cutting mat. However, I didn't want the mat to move around. I decided to make the mat a permanent fixture using contact cement. I glued the mat in the general vicinity of the center of the board so that I wouldn't have to deal with minute alignment issues, since the contact cement bonds the instant it touches. I could then cut off the excess around the edges of the mat for a perfect fit. Next, I rounded the edges of the surface using a handheld router. This is where the surface started feeling more like a table than just a plywood board. When I calculated that 6 screws would provide the necessary force to support the frame, I was able to cheat by assuming they'd be screwed into wood 1.5 inches thick rather than just a standard 3/4 inch thick sheet of plywood. This meant I needed to double the thickness where the frame would mount, so I created these 2 pads and glued them in place. After some sanding, the wood was ready to be finished with some Danish oil. The oil penetrates deeply into the surface, which provides some water resistance and also enhances durability. Looks prettier than raw wood surface too. When the frame returned from powder coating, it was time to prepare for the install into my office. Here, I pre-drilled some holes for mounting the table to the legs and the frame. The motorized legs came in handy as a jack to bring the table up to the frame arms. Here's this thing's final destination. I chose some high frequency LEDs from Waveform so that the duty cycle doesn't interfere with the frequency of the shutter speed and cause flickering in future videos with angles like this one. When seated at the desk, these bright LEDs don't just shine down on the workspace but also into my eyes, so I modeled some directional shades which could be 3D printed. This should snap right onto the frame of the LED housing. The shape of this part lent itself to parallel printing, so I was able to make all 8 at once. These little clips were supposed to help the shades fasten end to end, but they were slightly too small and delicate, so I started to just break them off before installing each one. The light switch and elevation controls were to be mounted adjacent to one another like so. I modeled and then printed this little switch box, which accepted a C8 connector in the back so I could run the power of the lights through it. Now that that works, all that's left is to mount some tools to the pegboard and call it a day.